call for a virtual discussion about the global fajr. Global fajr. It occurs when the sun is at its depression angle of -13 degrees. It is the first official video published as a collaboration between the Islamic Science Research Network, HAMKA Muhammadiyah University, Indonesia, and Open Fajr Project Team, the United Kingdom. Fajr and twilight. This figure portrays a rough classification of dawn and twilight for public usage in the aviation world, for hunting permits, regulations for car lights and street lighting. Begin morning nautical twilight BMNT and end of evening nautical twilight ENT. However, astronomers believe that even the astronomical twilight is still considered dark for civilian purposes. The problem: many Muslim countries in the world determine the commencement of the Fajr prayer when the sun is at its depression angle of even deeper than -18 degrees. The World Muslim League uses -18 degrees. Al-Qura University in Saudi Arabia uses -18.5 degrees. Egyptian General Authority of Survey uses -19.5 degrees as shown in this table. To scrutinize the occurrence of the real Fajr, the Islamic Science Research Network, Indonesia, in collaboration with the Open Fajr Project in the United Kingdom, has been applying dozens of modern sensors. They include the non-imaging sensor like a sky quality meter, or SQM, various types of DSLR cameras, dozens of gadget cameras, and an all-sky camera. For Indonesia and a small part of Malaysia, this Google Earth map shows the geographical coverage of our data. In total, currently, we have 245 days of astronomical data collected in 2015. And from 2017 to 2020. Our main instrument for the data collection was SQMs with additional imaging sensors like different types of DSLR cameras and gadget cameras of different geometric resolution. This slide shows a summary of our results. The highest sun's depression angle or dip is -9.35 degrees. In comparison, the lowest dip is -18.38 degrees, giving the population a mean of -13.24 degrees and a standard deviation of 1.81 degrees. The distribution of the estimated dip is relatively normal, as shown in this slide, which demonstrates the stochastic characteristics of the estimated dips. Meanwhile, the Open Fajr Project UK collected the astronomical data using an all-sky camera, which is a panoramic camera capable of recording the half-hemisphere in one snap. In total, there are 422 days of astronomical data collected in 2017 and 2018 in Birmingham. In the future, the Open Fajr Project plans to acquire astronomical data to cover all United Kingdom. The Birmingham astronomical data gives the highest dip of -10.43 degrees. The lowest dip of -15.70 degrees with the population mean of -12.98 degrees and the standard deviation of 0.99 degrees. The distribution of the 422 estimated dips is also normal, which demonstrates the perfect stochastic nature of the estimated dips, as shown in this slide. At first glance, the two populations' means look different. However, it strikes us to investigate as to whether there is equality in both population means. Modern statistics provide a precise statistical test to scrutinize the equality of the means of two populations. Both populations, i.e., Indonesia and Birmingham, have a normal distribution, as shown in the previous slides. In addition to that, we also know the standard deviations of the two populations. Therefore, we can apply z-statistics to test whether or not these two populations are equal. The only prerequisite is, we should be able to select some observations from each population to construct samples randomly. Ordinary spreadsheet software such as Excel is capable of handling such tasks efficiently. 5 steps of the statistical testing are as the following. Step 1. Declare the null and alternate hypotheses. We set up our null hypothesis to state that the population mean of Birmingham is equal to the population mean of Indonesia. The alternate hypothesis, therefore, states that these two populations are not the same. Step 2. Choose the level of significance. In this case, we select the significance level of 5%. Step 3. Determine the statistical test. In this case, we are using z-statistic as both populations have a normal distribution, while their population standard deviation sigma for Indonesia and Birmingham are both known. Step 4. Formulate the decision rules. The rules are: we accept the null hypothesis when the calculated z falls within this acceptance region, and we reject the null hypothesis when it falls in the rejection region. Step 5. Take samples randomly and make a decision. We apply Excel to select 40 observations from each population randomly. We then calculate the sample means and use this formula to calculate the z-statistic, where x bar with subscript b is the sample mean for Birmingham. X bar with subscript I is the sample mean for Indonesia. Square root of sigma with subscript b is the variance of the Birmingham population. Square root of sigma with subscript I is the variance of the Indonesia DIPS population. N with subscript I and b are sample size for Indonesia and Birmingham. In this case, they are the same, which is 40. Altogether, we constructed 256 samples of 40 random observations for each population. Out of 256 samples, 202 samples accept the null hypothesis. It is equivalent to 79%. Meanwhile, 54 samples reject the null hypothesis, which is equal to 21% of the total samples. These results firmly conclude that both DIP populations in Indonesia and Birmingham are statistically equal. It, therefore, allows us to merge these two populations into a combined population of 664 days as shown in this slide. The new population mean is minus 13.08 degrees, with its corresponding standard deviation of 1.37 degrees. However, the new population also reserves an effort to investigate the possible presence of any outliers. We, therefore, try to map the distribution of the corresponding z-scores as shown in this slide. Classical statistics give the standardized DIP value of 13.08 degrees becomes 0, while the DIP of 17 degrees transforms to 2.87. The table next to the graph shows that DIPs 18 degrees or more significant will give the standardized z-scores of larger than 3. Statisticians agree that the z-score larger than 3 is considered outliers and should be omitted them from the population. Conversely, the z-scores which are smaller than minus 3 are also outlier and should be discarded. Technically, when the z-score is more significant than 3 or lower than minus 3, we are unable to differentiate whether or not the data contains little blunder. Statisticians often call it as points of just undetectable blunder. The left table in this slide shows the sorted all 668 combined DIPs from smallest to largest. The table shows that there are 4 data having z-scores larger than 3. All data occur in Indonesia. 1 in Temanggung, Central Java, 2 in Makassar, South Sulawesi, and 1 in Biding, North Sulawesi. The right table shows the cleansed data from the outliers, which further gives a slight change in the mean and the standard deviation. The mean changes from minus 13.08 to minus 13.05 degrees, while the standard deviation changes from 1.37 to 1.32 degrees. The total number of cleansed data is now 664. It is the final stage of the estimated DIP and standard deviation for the combined populations. We might be interested also in comparing the physical appearance of the estimated DIPs as compared to the theoretical one. This table shows that the DIP of minus 16 degrees or deeper occurs 11 times, which counts 1.66% of the total number of 664 data. In the meantime, theoretically, if the amount of data close to infinity, the continuous distribution function gives a theoretical occurrence of 0.7%. This table further shows the physical and conceptual appearance of the DIP of minus 15 up to minus 9 degrees. The discrepancy between the physical and theoretical occurrence is practically less than 1%. It demonstrates the reliability of the estimated dips obtained. Conclusion. We proved that the mean of the sun's depression angle of the dip population in Indonesia and Birmingham is statistically equal. We, therefore, are allowed to combine both populations to obtain their combined mean of minus 13.05 degrees with its standard deviation of 1.32 degrees with the final results. It seems to be valid to set a new null hypothesis to say that globally, the fajr occurs at the same dip around minus 13 degrees. This scientific fact raises inquiries about why ISMA should use minus 17.5 degrees. Egyptian General Authority of Survey uses minus 19.5 degrees. The World Muslim League uses minus 18 degrees. Malaysia minus 18 degrees, Indonesia minus 20 degrees, and so forth. The following scientific facts support our inquiries. We collected astronomical data from June 14 to 26, 2019. To obtain the average dip of minus 11 degrees. Astronomical data collected in Cairo from December 16 to 2019 gives the average dip of minus 13.01 degrees. Follows the collection of astronomical data in Cairo. We collected data in Istanbul from December 21 to 26, 2019 to obtain the combined average of minus 11.50 degrees. Finally, Mr. Ahmad Rizal from Jakarta, Indonesia, sparks the idea of crowdsourcing mode data collection we propose in this video. He was performing Umrah in early February this year. He offered to collect the astronomical data using his low-cost gadget camera from his hotel in Medina, Saudi Arabia. We processed the image data using the image processing technique to find out that the fajr occurred at 6 hours 19 minutes and 51 seconds local Medina time, or when the sun was at the dip of minus 10.24 degrees. All these scientific facts make us of the firm belief that, globally, very likely that the fajr occurs at the sun's depression angle of around minus 13 degrees. It is by no means to say that twilight is the same all over the world. Despite the same sun's depression angle, twilight in the higher latitude is longer than in the lower one. The following table shows that assuming the sun is at minus 13 degrees of depression angle, twilight in Birmingham is almost 1 hour and 20 minutes on March 1, 2020. In the meantime, in Tacoma, which has a latitude of 7 degrees lower, the twilight is only 1 hour and 11 minutes. At the latitude of 41 degrees, the twilight in Istanbul is only 1 hour and 4 minutes. In Medina, at the latitude of about 25 degrees, the twilight is only about 50 minutes, while in Jakarta is only about 49 minutes. For other date stamps, this table shows the rest of the information. Globally, very unlikely to obtain scientific evidence that the fajr occurs at the sun's depression angle of minus 18 degrees, let alone minus 20 degrees. It is urgent that all Muslims in the world work together to compile the global twilight pattern through crowdsourcing scheme. Call for an international collaboration. 1. Let's work hand in hand to compile the global twilight pattern. 2. It is for the betterment of the quality of Muslims' worship all over the world. 3. We call for international collaboration to collect global astronomical data. 4. Use both imaging sensors, e.g. DSLR, high-res gadget camera, and non-imaging sensor, e.g. sky quality meter, to record the sky brightness. 5. Set up your equipment facing east. 6. Start recording 10 minutes before the fajr at your local time until about sunrise. 7. Apply temporal resolution of at least 10 seconds for both sensors. 8. Alternatively, if you wish, you can use naked eyes so long as you can provide the timestamp up to 10-second accuracy. 9. If you need any assistance, we are happy to process your data free of charge. 10. Your contribution will be acknowledged and highly appreciated. Assalamu alaikum wa rahmatullahi wa barakatuh. Thanks for watching.